So you can see this, right? Just give me an indication as you were seeing.
Yes, sir, we can see.
Yes, sir.
Great. Yeah. So the last day we looked at, we were looking at ratio and proportion. We talked about direct proportion, inverse proportion, and so on, right? Um, but there's still some other types of questions that um, sometimes those techniques that we learn under um, direct proportion and so may not be able to, we may not be able to solve them, right? Um, directly. We'll need some other additional techniques to solve them, right? And let me give you some examples of what I'm talking about. Let me just pull up an example quickly. Yeah, look at this one. All right, look at this problem. So they're talking about a sum of money to be shared. And notice, not just two, not just two parties are involved, three parties: Albert, Bruce, Christine. And our ratio doesn't have um, just two parts, like 3 to 7. No, it has three parts, right? So that tells you that we need another technique in order to be able to solve this kind of problem, right? The reason why I say this, right? Um, let me just contrast this with another problem. I just want to show you what I'm talking about. Here's a second problem here. Okay. Oh, I think I made one too big, one small. All right. Look at this problem, right? Here you're dealing with, okay, two lengths in the ratio 7 to 8. If the first length is 273, what is the second length, right? And we can use that direct proportion thing. That's okay. 7 to 8 will be equal to 273 over x, right? And you can quickly find x by cross multiplying, right? So you get 7x equal 8 times 273. X then will be equal to 8 by 273 divided by 7. And we get an answer, right? But that's not what we see here. We got three parts. How do you write a fraction like that now? You see, so we have to get a new technique, right? We have to have a new technique to solve something like this. So the ratio is not 3 to 7 or 7 to 10, it's 3 to 7 to 10, right? And they have some more technical information now. They say Christine received $495 more than Bruce. And you have to determine the sum of money to be shared. You see this problem, you just have to know what's the second amount, right? So it's a more technical problem that requires some other bit of reasoning and technique to solve, right? So let's turn our attention to this problem here, right? Put it in the middle here. Maybe I can erase all of it. Good. So here we have, let me put it, Albert. Let me go with Bruce here and Christine here, right? Christine. So it's 3 to 7 to 10, right? That seemed to be the order, right? Albert to Bruce to Christine is 3 to 7 to 10. So the question says, okay, you have to determine the sum of money shared. So you gotta get a total amount shared. So before you can get there, they gave us a clue here. Christine received $495 more than Bruce. So what we call these, right? We call these proportional parts. Let me write that. We call these proportional parts, right? That's what we call it. So this money that was shared, 3 proportional parts was given to Albert, 7 proportional part was given to Bruce, and Christine received 10 proportional parts. It is not to say that $3 was given to Albert or $7 was given to Bruce or $10. No. If you were to take the real money, right, the real sums that were given to the 3 of them, and you reduce the sums, right? You divide by a common divisor, or what you call the highest common factor. It will reduce those numbers to these 3 numbers, 3, 7, and 10, right? So just like how when you had, okay, let's say one person, forget this problem. Let's say one person was given $1,000, and the next person was given $3,000, right? When you reduce this is like a 1 to 3 ratio. Well, that's what's happening here, right? So it's like this person received 1 proportional part, and this person received 3 proportional parts, right? So the same thing is going on here. If you were to take the sums of money that Albert, Bruce, and Christine received individually, and you were to reduce them using the highest common factor, you will be able to reduce them to 3, 7, and 10, right? Think you get that? Good. So now they gave us a little clue there. They said that Christine received $495 more than Bruce. So that can give us an idea as to how much is 1 proportional part, right? So when you look at this now, okay, according to this, Christine received $495 more than Bruce. Now, how many proportional parts did Christine receive more than Bruce? So according to this, Christine received 3 proportional parts more than Bruce. Can you see that to be true? She got 10, he got 7. So she received 3 more. And what they're telling you here is that 3 proportional part is equal to $495, right? Do you see that? From that now, I notice nobody is responding, and so from that information, 3 proportional, I'm going to write out the word parts equal 495. From this, we can find what 1 proportional part is equal to. It will be 495 divided by 3, which is anybody going to help me tonight? I know nobody in talking, and so nobody in joining in.
R165.
Okay, you go, okay, nice. 165. All right. 165. Right? And the total sum equal to how many proportional parts? 10 and 7, 17 and 3, 20, right? equal
Yes,
20
sir.
proportional parts, right? Which is equal to 20 multiplied by 165, right? So you get 20 multiplied by 165.
Yeah. 3,300.
Yes. So that's the total sum share. You see? This method of finding how much is one proportional part, you will see the textbook say it's the method of unity, right? You're trying to figure out how much is one proportional part, and that can answer a lot of questions, right? In this one, you could already know how much Albert got because they said three proportional part is 495. So you don't know how much Albert gets. But to know how much Bruce gets and to know how much Christine gets, you'd have to, well, multiply the one proportional part by 7 and then by 10. But they didn't ask you that. They asked you what was the total sum shared. So once you know how much is one proportional part, and there are 20 proportional parts in all, right? And you see where I got this 20 from, right? It's the 3 plus the 7 plus the 10, which is 20, right? And if one proportional part is $165, then 20 proportional part will be 20 by 165. So the techniques we learned the other night just can't solve this kind of problem, you know? So they have these kinds of problems that will trouble you a lot. And they don't involve just, a pair, 3 to 7 or 7 to 10. You got 3 parts to the ratio, all right? There are 3 parts to the ratio. Let's do one more. Look at this one. So they say an alloy of steel consists of silver. Oh, sorry, no, it's not an alloy of steel. It's an alloy, right? So that's a completely different metal, right? An alloy is really a mixture of, of different metals to make up a new one, right? So an alloy consists of steel, silver, and copper, right? So steel to silver to copper in the ratio 6 to 5 to 9, right? Notice in this one again, they want you to calculate the mass of the copper alloy, right? So if you take a piece of the alloy, they say, all right, they say that 160 grams, right? They say if the smallest mass is 160 grams, right? So which is the smallest mass? It's silver, right? So silver, which makes up of 5 proportional parts equal to 160 grams, right? So for you to know the total, the mass of copper in the alloy, right? Copper is 9. So what we have to do is find, we have to find one proportional part. So one proportional part is going to be equal to 160 gram divided by 5, right? So when we divide that, what do we get?
32, sir.
Great, somebody is working with me. 32 grams, right? So now that we know one, they want to know how much copper. What's the mass of copper in the alloy? So copper, right? I could write out the word mass of copper equal to 9 proportional parts, right? Which is equal to 9 by 32 grams, right? That'll give us what?
288 grams, sir.
Great. 288 grams, and that's your answer, right? The mass of copper, if you want to write out the word, mass of copper equal 9 proportional parts. And if one proportional part is 22 grams, then 9 of them will be 288. Right? So this is the type of problems that you can also see in ratio and proportion, right? So the techniques we discussed the last day could not have, help us to solve these types of problems. Especially when 3 or more, the ratio consists of 3 or more parts. Good. So we've done quite a bit here with with proportional parts. We can move away a little now. And the other two parts of the topic, one has to do with percentage, right? This wouldn't take us very long. If you check the notes we were working with, they're talking about expressing one quantity as a percent of another, which will be a very useful bit of computation later on, right? Especially when we'll do what they call household arithmetic or consumer arithmetic, right? So this is going to be a valuable thing. So just as some examples, right? Like, okay, if they say, this is an example, you want in the notes there, express 975 cm cube as a percentage of 3 liters, right? 3 liters. How do you do that? Well, of course, you have to get liters in cm cube, right? So 3 liters is equals to 3,000 cm cube, because 1 liter is equals to 1,000 cm cube, right? So this is something you can find out and so on. Yeah. So to express 975 cm cube as a percent of 3 liters, we'll do this. 975 over the 3,000, and you multiply by what we call 100%, right? So the whole thing would have been 100%, but we have only 975 of the whole, which is 3,000, right? So when we calculate that, we get what? 975 divided by 3,000 multiplied by 100 will give us what?
I guess 0.325.
Okay, that's this piece here. And when you multiply it by 100, you get 32.5, right? Percent. Is not so?
Yes, sir.
975 divided by 3000 will give you 0.325. And then you
Yes,
multiply
sir.
by 100 and you get 32.5, right? Yeah. Look at it good. And that's a process. If you want to express one number as a percent of another number, make sure they're the same units, right? In this case, they were not in the same units. One was cm cube, one was liter. So you have to ensure that the units are the same. Then you put one on top of the other times 100%, right?
Yes, sir.
Then there was another one. Let's say you want to express a quarter as a percent, right? Or some people say percentage, some people say percent, right? But you put a quarter, multiply by 100%, and what you get? You should get 25%, right? If you have a decimal, express 0.75 as a percentage. You just put 0.75 times 100%, and you get 75%. Get that?
Yes, sir.
Yes, sir.
Look at a more involved problem. I'm cutting it. I'm bringing it over. Like somehow some mosquitoes got into my room. What? So you see this one, right?
Yes, sir.
So a school employs 30 teachers. How many teachers will be there if there's a 10% reduction? So here you got to figure out how much is this reduction in terms of numbers, right? How many teachers that means, right? So we find out, all right, 10% of 30 teachers, right? Will be how much? 10 over 100 times 30 teachers. You don't have to write teachers all the time. You could just calculate without the unit like. And in this case, it's teachers, right? You work without it, and then at the end, you put your answer in terms of teachers, right? So 10% of 30 will give us what?
3, sir.
3, right? 10% equals 3 teachers, right? Teachers. Good. So after the reduction, there will be, well, there was 30 minus 3, right? Teachers,
27.
right? And so we'll have 27 teachers, right? So it's a little more involved. Think you get this one? Is this difficult?
No,
No,
that
sir.
easy.
Oh, okay, nice. I like that. All right, let me take another one. Maybe this is the last one for now. Calculation of percentage is very simple, but very useful. They might, you know, you might not find a calculation that is as useful as calculating percentage in your whole everyday life, you know. Look at this one. 42% of a crowd of 38,500 at a football match were females. How many females attended? Right? They can even say that, all right, let me change it to how many males attended. Right? So 42,000 of the crowd were females. So how many were males? There are different ways you can do this. You can find out how many females were there and subtract it from 38,000, right? 500. Or you could also say, well, all right, if there were 42 females, what percent will be male? How much percent?
Sir, 58%.
Great. 58%. All right, let me write that this way. Or I'll find fault with how I write things. So 58% were males, right? So how much does 58% represent? 58 over 100 times 38,500. Right? And that will give us what?
Sir, 22,330.
22,330. What? This person who is answering me all the time here.
Anselmo, sir.
Ansel, remind me to give you an extra mark, man. You are quick. You're with me in the class. You're following me. You're helping me. Nah, you gotta get more than one. Remind me when this course ends. Let me give you an extra mark or two.
Thank you, sir.
Yeah. I can't do you so bad. Very good. Right? So these are the type of problems that, you know, they can throw at you when it comes to percentages. But I'll tell you what, percentages, you see it every day in your life, right? Lots of times statistics is reported in percentages, you know. Everything you read, you hear, inflation went up by 5%. You want to know what I mean by this, right? You always know how does measure inflation, and so
No. How?
what they look at? Okay, let's say there's something called all right. When they talk about inflation, they can very well talk about the increase of the price of something, right? Like they will actually take some common goods that let's say they say, all right, consumer goods went up by 5%. Not everything probably went up by 5%. Some probably went up by 10. Some probably went up by just 2 or 3. So what they will do, they will take a group of, let's say, grocery items that you and I would regularly use. Like, okay, for Guyana, you say rice, oil, sugar, salt, flour. And those are the main things you buy at the shop. Potatoes.
Yes, sir.
Right? So they'll take those prices and they'll watch, well, all right, what it was, let's say, last week and what it is this week. Right? And when they finish with all of that, maybe I'll give you a question like that to try out, maybe in your next test. Right? when they take all the prices of all these things and they add them up, and then they take the price of all of them now and they add them up. Maybe for 1 pound, how much for 1 pound, of rice or whatever, and they add them up. And then they take the price of it this week, and then they subtract the two. So all right, let me write that out. I think it's, as I speak, it's too confusing. So all right, let's say, and I'll put it this way, a basket of, let me use it, consumer goods cost, let me call it $5,000 in October. The same, and that's what they do. They use the same goods, right? Whatever is in the first basket, the same basket of goods cost $8,000 in what's this, November, right? November. What was the rate of inflation? What is, I'm spelling this word is FANFLE, right? I don't know what this is. What is the rate of inflation for the last month? Right? Simple. So they take, normally that's what they do. They take, all right, 1 pound sugar, 1 pound flour, maybe 1 pound rice. They take a certain essential goods that everybody would buy every month, right? And they see, well, how much does it cost, right? And let's say it costs $5,000. And the next month, that same set of goods costs $8,000, right? So what do we do now? Percent inflation equal to 8,000 minus 5,000. And they put it over 5,000. They use that as the base, what it was last month as the reference, times 100%. And you get what? You get 3,000 over 5,000 times 100%. Oh gosh, I put an extra, 100%. And you get what? You get 60%?
Yes, sir.
Yeah, right? You get a 60% inflation, right? That's how they calculate the rate of inflation, right? Sometimes when they talk about inflation, they're not as a matter of fact, there is something called the consumer index. If you all ever do a course in economics, right? The consumer index, you almost research this. And that is more, it's basically what I'm talking about here. They take a set of goods that, that are essential to people's survival, what they would buy, and they do a calculation, and that consumer index is what tells you whether things have gone up or gone down, right? Sometimes when they speak of inflation too, they also speak of not necessarily consumer goods, right? They can consider other things, right? Like they can very well talk about, okay, gas, right? They can factor in gas, because people say, look, when you talk about, when you want to measure inflation, you can't just talk about things people eat. You got to think about cars, and what they would use. So inflation And it can be, you can talk about a particular goods and the inflation of that goods, right? Like gas. Gas might be $200 for a liter, and now it's 220. But you would say, well, what is the inflation rate on gas? Right? So it doesn't have to be a collection of consumer goods. Right? But you almost, if you have some time, research consumer index. It's a good measuring rod of how things are going up and so in the country. If you go on later on to study some economics and so, well, you're going to be able to understand that some more, right? All right, good. So do you want a little break before we do our last subtopic? You want to take a
Yes,
break?
sir.
Maybe we take a what, 10 minutes or 15?
Sir, 10 is okay.
So we come back at 6:20?
Yes, sir.
All right, good. Pause and come back at 6:20 and then, good. So our last bit this evening, we're gonna look at what we call the arithmetic mean. You hear of the average, right? And again, this is something you hear very often in the real world, right? People speak of average, average score in a number of tests that you do. You hear of cricketers' average. You hear of a lot of things where the average is used, right? It's basically like a single number that you want to represent various let's say scores by, right? So let's say maybe somebody, let's say a cricketer, name who's a good Guyanese batsman. You got any good Guyanese batsman in the West Indies there? The team or the CPL team? I don't know.
I don't watch
Shepherd.
cricket.
All right, let's go with Shepherd, right? Let's say Shepherd and his batting average. Shepherd's batting average, and maybe he scored in one. He scored in one match, let's say 30. Then he scored a 50. Then he scored an 11. Then he scored we go a 15, and then maybe another 50, right? So how much is it? 1, 2, 3, 4, 5. So he did 5 matches. So let's say you're looking at him. You say, man, look, what is this man's batting average for the last 5 games? So his batting average is going to be equal to, you take the 30, add it to the 50, you add it to 11, 15, and the 50, and you divide it by 5, right? And how much will that be? $156 you get? Anybody you adding? 156?
Like 116.
116? It can't be 116.
Wait,
This 50 and this 50 is 100. This is a 30. That's 130.
oh shucks, I had wrong. I had wrong.
Yes, sir.
I had wrong.
So
It's going to be 31.2.
good. 31.2. You see? So this number now, 31.2 runs, right? That's what you're adding there. So his batting average is 31.2 for the last 5 games. And that's what they use, that's what they use when it comes to let's say they're buying players. Like when the CPL, the IPL comes around, they look at your batting average. For him, he's a bowler, right? He's a bowler. They look at his average number of wickets over the last 10 matches, 20 matches. You know, I don't mean this is the only thing they look at, right? They look at other things, but they look at your batting average. If you're a bowler, the number of wickets, the average number of wickets, right? And they use that now to say, well, all right, whether they should buy you, right? And people who got high batting averages, you know, like you all know about Puran, you all know of Puran, Nicholas Puran, Kohli. I don't know how you spell his name, by Kohli, something like that. Puran, Kohli, them guys, his batting average is 50 and over, right? And that's why when it comes to buying them for tournaments, you have to pay hundreds of thousands of US, right? I think one year I was watching how much they paid for Puran for the IPL, and it was nearly what you call 2 crore, right? When I checked, the 2 crore is nearly 2 million US. Not quite, right? Even if it's just about 1 million US, that's a lot of money for a man to play for 2 or 3 months, right? It's about 2 months that thing run for, right? So that's a lot of money. But their batting average is what you hire them by, like men like Puran and Kohli. Because they don't bowl. They just bat. So having a high batting average is very important, you know. So back to how do you calculate the arithmetic mean, right? And this is a little formula. Yeah. All right. So this is the way you calculate it, right? You find the sum of all the quantities by the total number of quantities. You divide it by that. And that will give you the arithmetic mean or the average. Right? Very simple, like I showed you just now in that example. Right? So maybe we can do another example or two. Let me do an example more. Something is happening here. All right. Look at this one. Okay. All right. Let's look at this one. Good. So look at this. So this person, they did 9 tests, and these are their marks for each of the tests. No? These are all the marks. So the question asks you to calculate the total number of marks in all the tests. Right? So you add all those up. And then they ask you to determine its average. So this average, right, is average. And this is a good measure of how you're doing overall. Average marks equal to, and you add up all, 79 plus 84 plus 55 plus 49 plus 95 plus 64 plus 73 plus 97 plus 88, and you divide by 9 of them. Somebody help me, please.
76.1.
Okay, all right. So I think it adds up to 684 marks over 9 tests, right? So you'll get 76. All right, let me go to the nearest whole number, maybe. Marks for test. Oh, what would you say of this person? Is he a good student?
Yes, sir.
Yeah, you would say that, right? One, I would say like, okay, maybe these two courses or subjects he needs to pay attention to, right? And to a lesser extent, this one here. The others he's doing very, very well in, right? This is a good student, right? But you see, you made that judgment based on his average marks, his overall. You can't watch the 49, nor can you watch the 97. You want to know overall, is guy all right? And yes, he is a good student, right? Good. Listen to this cricket one now. And here is where this other formula, at other times, this formula here, let me go bring the formula. There's another formula that is very useful, right? This formula here. Yeah. So remember, the arithmetic mean was equal to the sum of quantities divided by the total number of quantities, right? But we rearrange it now, and you have the sum of the quantities equal the arithmetic mean multiplied by the total number of quantities. This is a very useful formula, right? Let me show you problem that this formula might very well be useful, right? Let me bring it over here. All right, something is happening that I can't. All right, good. Look at this one. I don't know if you can see it. So they're
I
saying
have a
9.
Zoom.
Huh? You want it bigger?
Yes, sir. Just a
All right,
little.
all right, good. That should do the job, right?
Yes, sir. Thanks.
Good. So they say in 9 completed innings, a batsman average score was 47. After a further innings, his average score increased to 51. How many runs did he score in his 10th inning? Innings is like, okay, the last game, in the 10th game. Every time you play a match, you call it an inning. I know you don't watch cricket, some of you. Right, so good. So here, they tell you that, okay, his average was 47, right? In nine matches. So the sum of quantities, the total runs in 9 innings would be equal to 47 by 9. Tell me what that is.
$423.
423, sir.
423, good. From the other piece of information, after further innings, his average score increased to 51. So in 10 innings now, the total number of runs in 10 innings would be equal to 51 now by 10, which is 510.
Yes, sir.
So if in 9 games he made this amount of runs, and in 10 games he made this amount of runs, how much did he make in his 10th game? Number of runs in game 10, right? Or innings 10 would be equal to 510 minus 423. Which will give us
87,
what?
sir. 87.
See? So you see why this formula is useful at times?
Yes,
You got
sir.
that form? How to, yeah. Right? That's a very interesting application of this formula here, right? I'm looking for a harder one. I'm not seeing anything. There was one that I'm not seeing it here. All right, look at one more like that. Let's go with this. All right, look at this one. Very similar. So Anne's mean mark after 6 results, or maybe she got back her scores then for 6 different tests, was 68. Her mean mark dropped to 59 when she received her 7th result, which was for Spanish. What was her Spanish mark? So what we need to do then is, okay, you have to find Anne's total after 6 results, right? 6 results, which is 6 by 68. Somebody will give me.
408, sir.
Okay,
408.
nice. 408, right? Marks, right? You don't have to write all that. Good. Anne's total after 7 results now would be what? 7 multiplied by 59, which is
413.
413 marks, right? So you can see what she got in Spanish. Anne's mark for Spanish will be equal to 413 minus 413 minus 408. She did horrible.
5.
5 marks, sir.
5, yeah, right?
5.
She flunked Spanish, right? So you see the kind of problems, right? That you
Yes,
can
sir.
come up against with this whole thing about the arithmetic mean, right? So go through the notes I sent you on the arithmetic mean and look up some of those questions they have and see if you can handle them. I promise I will send you all some questions. I didn't have the time, to be honest. I worked all day today, but there was a blackout and I lost about an hour or 2. I can't remember. We're having blackouts every day, sometimes 2, 3 times a day. So we're losing a lot of work, work time. But I'll send it before Friday, and we'll have a normal class maybe on Friday, and maybe next Monday we'll do a bit of presentation on those, right?
Okay, sir.
Yes, sir.
Right, good.
Okay,
So,
sir.
We're going to end the class here,
Yes, sir.
right? I didn't